we had few hiccups in between. No problem. So we were discussing about what components can be virtualized. So in the first unit, you would have come across the virtualization process entirely, and there you would have learned that many types of virtualization is possible, and many entities of computer system is also possible for virtualization. And you had seen process virtualization, full virtualization, or para virtualization, or even system virtualization, on bare metal virtualization, many types of virtualization you would have come across. But here in the third unit, we'll be focusing on the cloud components which can be virtualized. So as of cloud is concerned, you could come across only servers, storage units, network entities, and power supply can be virtualized, right? Because these are all only the things in the cloud what we are interested upon. Okay, so you can name any server, and it can be hosted on one particular physical server, and obviously these physical servers, okay, these physical servers can host any kind of server to any extent of scaling, provided it should have that much particular capacity. That's it. Okay, now moving on to the second one, that is the storage, where the storage also has to be virtualized, definitely. Why? Because you will be having multiple servers to cater different type of needs. Okay, it can be web server, it can be database server, or it's a kind of an example only I've taken. Okay, so definitely whatever the consumption you are taking, you are going to use in the cloud, definitely there should be some sort of database consumption also, and hence you got to save your data. So for that, not only the physical servers are sufficient, you are supposed to have the virtualized storage units. Okay, in the next part of the unit, we'll be discussing something called as how this particular storage units can be discussed. Okay, that's about the storage. Okay, in short, I will just tell now itself. In the cloud, you will call it as LUN, that is logical unit network. Okay, so these things can be treated as one particular storage unit or one particular network unit. Okay, so that's about the storage part. Now, when it comes to the network entity as well, definitely we'll be coming across many types of network in the many types of network connectivity is possible within the LAN, and also you can come across network devices across in the network, isn't it, right? So when you talk about an enterprise kind of network, which usually the cloud will be catering, isn't it? So there you will be coming across many routers, many switches. Why? Because the packets has to be routed appropriately, and they need to, depending upon the network, they need to switch their paths as well, isn't it? Okay, so these things are entirely handled by the routers and switches, and even hubs as well. Okay, so all these three what I just now named, okay, as part of the network, as part of the network has to be as part of the network has to be virtualized. Okay, they should be, I mean, their virtualization also should be supported. That's what we are intended here. Okay, and apart from that, last one is the power entity. That is nothing but the power connectivity, or else in layman words, the current connection. Okay, so these things also has to be replicated, or else in a virtualized. Okay, so I mean, you can just understand, like when you are creating a VMware on one particular individual machine, your power supply is basically on a physical server only. Your power connection will be only for the physical server only, but not for the virtual server. Do you think you can control upon the SMPS? No. What literally you are doing is, you are able to convert that power to in the form of virtualization as well. You can extend that power connectivity to the virtual network as well. See, remember, whenever I was talking about the server, storage, or network, or I mean to say connectivity network and the power supplies, I don't talk in terms of an individual system. I mean here in terms of entire cloud network, which means that you will come across many systems. You will come across many systems, and you will have a jungle of systems for that matter, I can say. So when usually when one or two machines, or else for hundreds of machines, these things will not be a real problem in having the virtualization of these entities as well. But when you're scaling upon thousands of systems, and that too globally placed, and with in order to provide high availability, okay, all these things has to be mandatorily possible. And the third part is the hardware independence. Hardware independence. As I told, the clouds are not portable, but cloud entities are portable. I mean to say, within the same cloud, you should be able to port your own devices. That means the hardware independence should be very much limited. Why? Because as of the virtualization host is concerned, okay, virtualization host is concerned, it can undergo changes. It can undergo changes. It's as simple as that. For example, if I'm hosting the VMware machine, or else if I hosted virtual box, okay, probably at this point of time, I am launching that virtual box on a Windows machine, that too Windows 10 machine, I can say. But at later point of time, when Windows gets upgraded, maybe I should be launching it in higher version of Windows, or else lower version of Windows. I mean to say Windows end user, that is user editions. Maybe I need to push that to some server edition as well. See, all these are all different platforms, isn't it? Though the provider, the Windows is the standard name, but you can come across many such versions, isn't it? Similarly, I can have this VMware or VirtualBox running on Linux machines. Okay, so the image what I had created on Windows, okay, so that should be equally working on the Linux host as well, on the Linux host as well. That means on the host operating system, when I'm trying to launch and create certain virtual devices, or else some virtual entities, these virtual entities should be working independent of the host. Whether they are created on Windows or whether they are being used on Linux, it doesn't matter. It should not show any such type of impact. That's what we call it as an hardware independence. Okay, and the server consolidation is the next component in the virtualization technology, which enables that many servers. As I told, we'll be talking about jungle of systems in the cloud network, and hence you will be coming across multiple and varied kind of servers. So all these servers at some point of time has to be sharing certain or else common physical servers. Common physical servers. Now, while sharing such common physical servers, definitely there should be some sort of consolidative arrangement of these servers. Consolidative arrangement of these servers. Students, I would like to give one example. See, in Windows, have you ever observed something called as disk defragmentation? Disk defragmentation. Do you know how data is stored on the disks? Whenever, okay, you very simply copy the data into certain drives like G drive, F drive, or H drive, or C drive, D drive, isn't it? But do you know where exactly, or else how those data will be stored? On the magnetic strips, on the sectors, of course, okay, the data will be placed here and there. Data will be placed here and there. And definitely when you try to search, or else when you try to retrieve certain data, it might take time. There is a feature in the Windows, something called as disk defragmentation, where if you run the disk defragmentation, it identifies the storage units sector by sector, okay, and reorganizes and rearranges the data storage. The data storage. It is something like, you had shelf, okay, you had shelf. When you automatically step into room, you just throw your books into shelf and you take some rest, okay. At some point of time, you go out and you come back, you remove your dress and you throw that into the same shelf. So you could see clothes are in the same location, and in the books are also in the same location. Might be even your footwear can also be in the same location. But at later point of time, when you get some sort of patience, okay, so you try to rearrange, you try to clean that, okay, you will see that books are placed appropriately in certain part of the shelf. In clothes, you will be folding and you will be keeping it in another sense, okay. And any other, these kind of things, pens, all the pens you will be keeping at one side. So mobile chargers or mobile, likewise, you'll be rearranging your shelf contents, isn't it? So this is what basically the disk defragmentation does. Okay, this is what exactly happens. Now, why I was referring this as an example, because when you have one single physical server and when you're talking about multiple virtual servers, you on a initial stake, okay, it will be placed here and there. That is it. But as a cloud administrator, it becomes your responsibility to verify, okay, to verify how these particular what how much amount of space is being consumed and how much amount of space still you have ready. Definitely you need to have that sort of statistics in order to understand when to scale, when not to, and to accept new customers or not. Likewise, kind of business decisions you got to make upon. Okay, so for this definitely you have to take care of the consolidation of existing servers. Very now and then you will be having to take care of the server consolidation. In other sense, I can tell you, few people will be bringing only one notebook for all the subjects. Still, they could be making up only, and that person will be knowing where exactly he has written on what topic. But if the same book is given to other person, he will not be able to identify for a certain topic that he has written. You got it, okay? So that is the importance of consultation. That is the importance of consultation, okay? Or it's as simple as that. In the cloud, definitely there will be only one physical server on which multiple and varied types of virtual servers will be there. But here and there, server should not be placed. And for taking the business reasons into the consideration, or you definitely has to get the statistics upon your servers. So to provide that particular statistical data, okay, servers has to be consolidated, and that server consolidation should be made possible here in the virtualization. In Windows, disk defragmentation is one such particular feasibility. But in other operating systems, I don't think so. That sort of defragmentation facility is available. I'm not much sure. I mean to say, when we try to look such kind of feature in Linux, I'm not sure whether it is available or not. Okay. So similarly, when you're talking about physical servers and virtual servers, it should allow you, okay, that feasibility. There should be some sort of feasibility for you to consolidate on your servers. And next one is resource replication. This is one more important and very crucial component of the virtualization technology. You very well know that the scaling of the devices will be happening, and how this particular scaling will be happening. Definitely, the resource replication will be keep on increasing, keep on increasing. I will tell you one classic example here. Okay, when you're trying to create a virtual system, okay, so there will be certain option to choose upon the hard disk size. Okay, let us assume you have chosen 20 GB hard disk. Okay, but 20 GB, it will ask you whether you are supposed to allocate this 20 GB at a time, or as and when it can grow, as and when it can grow. So usually we will not ask for at a time allocation, but we will ask for whenever it is growing, it has to grow up to 20 GB. That means as of now, when I create the virtual system, initially probably all the 20 GB will not be available, and only let us assume 2 GB is available. Okay, 2 GB is available, and that 2 GB will be growing upon when it depending upon my usage of that particular system up to 20 GB. Yes, this is fine. Okay, but there is one more feature in the VMware that thinking about the portability, it is really difficult for us to port 20 GB of content as a single file. As a single file. So what we usually do is we try to cut down that into chunks. So while creating the hard disk itself, you can create such chunks. That's the beauty of virtualization. That's what we are talking about, resource replication. Okay. So the beauty of virtualization lies in creating chunks of your resources, chunks of your single resource for that matter. Okay, so what I do is I enable certain option that I will be needing all these hard disks in multiple sizes, or else in smaller chunks, where even I can choose that chunks size as well. I can choose the chunk size as 1 GB, or I can choose the chunk size as let us assume 2 GB or okay, 2 GB, let us assume. Okay, so in the same example, when the operating system starts growing, okay, so at the first it creates one hard disk. Okay, that's what hard disk size is, 2 GB. Okay, now for the 2 GB there will be one small chunk will be created, okay, with an extension vmdk. That's what you're seeing on the screen as well. Okay, and this hard disk starts growing, isn't it? When I start using that virtual machine, automatically it starts growing. Okay, so that has grown to another 3 GB. Okay, another 3 GB. That means initially I had 2 GB. Now I'm having totally 5 GB. So how many chunks? I told that each chunk can be of 2 GB size. So how many chunks it could be made? 2 plus 2 and another one chunk, that is 1 GB, isn't it? That means totally 3 chunks are being made. Similarly, up to 20 GB, how many chunks I can have? Close to 10 chunks I can be having, isn't it? You understand? Okay, so these chunks should be replicatable. These chunks should be migratable. These, why these are being created is only for the maintenance purpose. Only for the maintenance purpose. See here in the yeah, on the screen you could see an image, sent OS 5, that is sent operating system, which is an Linux one, and here the one S001, which means that hard disk first chunk. VMDK is the extension of VMware hard disk. VMware hard disk. Okay, similarly second one is sent OS 5002. That means this is the second part. Similarly the third part. You got it? That's how the chunks have been created. On the other hand, you can also see Windows XP Pro hard disk 2. These are all hypervisor devices. These are all hypervisor devices. Okay, so in this way, the resource replication should also be supported. Okay, and next one is how many types of virtualization. Okay, we'll be discussing here very on a lighter vein itself. We'll be discussing. Okay, so there are two types of virtualization is possible. One is operating system based virtualization, and another one is entirely on hardware based virtualization. That means one type of virtualization, you need to have an operating system on which the virtualization software will be running, where you will be creating the virtual entities. Best example is now you people would have created virtual boxes or else virtual machines on your laptop, let us assume, or on the desktop. So in the desktop, okay, basically you will be having certain operating system, that is nothing but the host operating system. On this host operating system, there will be one layer of virtual management that is happening. That means when you run the VMware or else when you run the virtual box, okay, that application creates this particular virtual layer. Okay, on this virtual layer, you will be creating much more machines. That means when you open that VMware software, or else VMware player, or else VMware server, or else VMware workstation for that matter. Okay, in that workstations, probably you could host two or three machines. Say one I can host Windows XP, or else I can host Windows 7, or else on the other hand I can host Linux machines, or even in the Linux I can host Red Hat, I can host CentOS. Any number of virtual machines I can be hosting upon. So that's this kind of hosting. Okay, this kind of creation of the whole guest operating system, you call that as operating system based virtualization or host based virtualization. Why? Because for having this virtualization, you should be needing one particular host. So here in the diagram, you can see that hardware is present on which the operating system is being hosted. On this operating system, you will be coming across virtual machine management software, which forms a layer for you to create the guest operating systems. And you could see three guest operating systems have been created. But the problem with these kind of virtualization is usually it will be difficult for a resource administrator to monitor the things and to estimate the resources consumption, and to manage especially, and to manage these resources. Okay, at some point of time, you will not be able to cater all the three operating systems, all the three guest operating systems. Okay, so it will be a kind of a difficult task for the administrator to take care of the resource planning and administration if this is the kind of virtualization technology followed. On the other hand, you can come across a hardware-based virtualization where there will not be any operating system in between. On the hardware directly, there will be there will be one virtual management software, which usually we'll be calling it as hypervisor, which we will be calling it as hypervisor. Okay, so on this hypervisor, okay, we will be creating the virtual machines. See, the best example for previous one, that is operating system based virtualization, you can see VMware VirtualBox. Okay, and even Ubuntu also, you can no, Ubuntu is altogether, it's a different story. It works on kernels. Okay, so even that, yes, you can consider that one also. That's again, it is hosted on the operating system kernel only. So for operating system based virtualization, you can consider examples as virtual machines, VMware, VirtualBox, and Ubuntu. But on the hardware based virtualization, you can see that virtual IRN and Zen architecture and hypervisor are the classic examples for the hardware based virtualization. Why? Because here they don't need any operating system, guest operating system. Though hypervisor you will be finding only on Windows operating system, but actually it hosts on hardware entity itself. It hosts on hardware entity itself. Okay, so usually if this is the case, if hardware based virtualization is followed, there will not be much difficulty for the resource administrator to monitor upon the resource consumption and to decide when to scale and when not to. But the problem here is there will be a compatibility problem. Usually the hardware compatibility problem is much anticipated here in this type of virtualization. On the other hand, definitely you need to take care of administration entities of virtualization. As I was talking in the previous topic, definitely you need to keep on constantly monitoring how the resource consumption is happening and how the resources are being consumed, so that according to the SLA and according to the business decision, whether the resource scaling is to be happening or not. Okay, so for all these things, definitely there should be one sort of virtualization infrastructure management. In short, we'll be calling it as VIM or VIM. Okay, and many of the administrative tasks are to be automated here. Similar to that of data center technology, you can come across many such automation tasks that can be automated. Well, that means very repeatedly these tasks are to be done, and at regular intervals, of course. Okay, and you need to have utmost accuracy, as you are not supposed to breach the SLA. And apart from these, other considerations you can be considering in terms of performance. That means when you have more operating systems or else more virtual devices host, probably the physical servers performance might be lagging, or you need to take additional care for the physical system to sustain its performance. Okay, it's a very common problem when you open multiple programs, or else when you open multiple applications on your laptop or mobile devices, automatically you can find a lag in its speed access, isn't it, right? And the other thing is hardware compatibility. Definitely, many players are there, many hardware players are there, but not multiple cloud players, you can see. So because of these reasons, okay, you need to take care of specific and special hardware compatibilities. Okay, say for example, I can tell that any operating system that is created on Mac machines cannot be used directly on other operating systems. Definitely. Why? Because its architecture, its organization itself, that is its operating system organization itself, is a different story. Everything will be a file in Mac. Okay, so that's the kind of thing. And other consideration what you need to think about in the virtualization technology is the portability. Usually, as I told, in the cloud, the portability among the cloud operators is not much feasible, but portability among the virtualization entities is very much possible. That means I can I can create one operating system, that is my host operating system on VMware, and maybe I can have it running on VirtualBox, which is not ideally possible, but the end user's entity will be in such a case, or else the service which is running on the system, on the virtual system that has been created using VMware, might be I need to port that service to another operating system which is running on, which is created on VirtualBox. Might be as the end user, I should not find any difference in my service catering. Okay, so these things being the virtualization technology components that enable the cloud.